All right, welcome back, Algebra 2. Let's go ahead and do one more example with these simple rational functions. Here we have negative 1 over x minus 3 plus 2. So what is that going to look like? Let's go ahead and identify our a, h, and k. So our a is negative 1. It's negative, so we know there's going to be a reflection, a vertical reflection, right, in this case. Our h is 3, and our k is 2. So we know two pieces of information right off the bat. We know our vertical asymptote is x equals 3. And our horizontal asymptote is y equals 2. Okay. And then let's go ahead and find some points around the vertical asymptote. So around it, we'll go ahead and use 1, 2, skipping 3, 4, and 5. So we'll use 1, 2, 3, 4, and then 5. Okay, this one might take a little more work, so let's do those. So f of 1 is equal to negative 1 over 1 minus 3 plus 2. So figure this first. We have negative 1 over 1 minus 3. 1 minus 3 is negative 2. Negative 1 over negative 2 is just 1/2 plus 2. 1/2 plus 2, that's going to be 1/2 plus 4/2, which is 5/2. Okay, so 1 is with 5/2. Let's do f of 2. F of 2, we go ahead and plug in 2, so negative 1 over 2 minus 3 plus 2. 2 minus 3, that's negative 1. We get negative 1 over negative 1, which is positive 1. Oopsie, not negative 1. Positive 1 plus 2, that's going to be 3. So 2 is assigned to 3. Let's plug in 4. We get negative 1 over 4 minus 3. 4 minus 3 is 1. So this is negative 1 plus 2, which is 1. And then f of 5 is equal to negative 1 over 4 minus 3. Ooh, sorry about that. 5 minus 3 plus 2. Negative 1 over 5 minus 3 is 2, so negative 1/2 plus 2. This is going to be negative 1/2 plus 4/2, which is 3/2. Okay, I kind of went through that a little quickly, so if you need to recalculate those on your own, go ahead and do so. But I just kind of wanted to do that a little quickly to show you how to plug it in, but then to kind of keep going, right? So let's go ahead and plug that stuff in. So we'll go ahead and scale this by ones. Okay, just using all quadrants here, but mainly the first quadrant, because that's kind of, if you notice all our values, that's kind of where it's going to be. Okay, so 1, 5/2. 5/2 is 2.5, so right here. Let me use a different color. Actually, before I do that, let's graph our asymptotes. So here's our horizontal asymptote. Asymptote, I don't know why I said it like that. Asymptote, y equals 2. And here's our vertical asymptote, x equals 3. Oh, let me try to put that more on the line. Okay, x equals 3. Always label them so we know that there are asymptotes. So then, let me use yellow to graph it then. We have 1, 5/2, 2, 3, there, 4, 1, 5, 3/2. 3/2 is 1.5, 1.5. It's right there. Okay, so you kind of see it a little bit. We have this as our picture, as our graph. Okay, and we'll go ahead and graph these in Desmos towards the end to show you, to confirm to you that this is not just something I made up. This is actually what these graphs look like. Okay, so the yellow in this part or in this graph is the main pieces of the graph. These are our asymptotes. They're quote unquote part of the graph, but they're not the actual graph of the function. They're just kind of boundary lines. You can think of them. You can think of them like fences, right? When you have, if you have a house and you have a fence to your backyard, or if you live in an apartment with like one of those like enclosures for like your patio, your backyard, or like if you don't have one of those, or if you've ever seen a house with like a fence, you can kind of think of it like that. Okay. Something I forgot to do in the previous problem, we'll go back and do it. Domain and range. So domain, range, pretty informal for now. We're gonna formalize this when we get to the next type of function. We just don't have time for it right now. For the domain, normally we're going to state all of the x values that the domain can have, and same with the range. But for now, to make it easier on us, we're just going to state, we're just going to imply that it's going to be all real numbers except for whichever ones we say. So what's our domain? Well, we can't have x equals 3 because we have an asymptote there. Okay, so our domain is everything, but x is not 3. Okay, x can be anything else except 3. Okay, for our range, y equals, or y is not equal to in this case, y can't be 2. So our range is everything y except for 2. Okay, so for now, we're just going to kind of keep it simple like this. We'll go ahead and make it a little more formal when we talk about the next kind of function in chapter 6. But for now, we're just going to kind of keep it a little informal. We'll go back to the top one. What's our domain and range here? Okay, well, our domain x cannot be 0. That's our vertical asymptote. And our range, our y cannot be -5. Okay, sorry for missing that on this first one. Okay, so, ooh, kind of sent to another dimension. So, sorry, I lost my train of thought for a second. We'll go ahead and kind of talk about these simple rational functions. We're able to make them look a little different. We kind of mentioned earlier that our rational function in general looks like p of x over q of x, right? It looks like one fraction. Although this doesn't look like it, we can make it look like it. Let's see how. So we have -1 over x minus 3 plus 2. If I want to get it to one fraction, well, I add these two. I actually do the addition. Before I do that, though, I need common denominators. The only denominator we have is x minus 3, so let's multiply 2 by x minus 3 over x minus 3. I get -1 plus 2 times x minus 3 over x minus 3. I kind of just shortcutted the operation a little bit, but this is why we did 8.4, 8.5 first. That way we knew how to add these together. We get -1 plus 2x minus 6 over x minus 3. So that becomes, let me push this down a little bit, 2x minus 7 over x minus 3. Okay, so another way to represent this is a way to represent the simple rational function, but as the thing we started with at the beginning, with the p of x over q of x. You're going to find that we're going to see this a lot more often than the transformation version, but we kind of wanted to do the transformation version to kind of get us there, okay? So from here on out, we're mostly going to see our rational functions expressed like this as just one single fraction. Okay, so then an important note there then is now the issue. We can still get our vertical asymptote from this because we just set our denominator equal to 0 because we don't want our, we want to figure out what makes the denominator 0 and then use that information to get rid of that x value. So then how are we going to get a horizontal asymptote? Okay, well, something I just want you to believe for now about the horizontal asymptote, just believe it for now, we'll talk about it in 8.3, is if the degree of the numerator is equal to the degree of denominator, the horizontal asymptote, you can find it by dividing, so divide the leading coefficients of the numerator and denominator, okay? So here our horizontal asymptote was 2. We can get that by over here. Leading coefficient is 2 over 1, implied 1 there. 2 divided by 1 is 2. Okay, you might be like, where does that come from? We'll talk about that in 8.3. For now, just believe it, okay? I promise we'll talk about it. Let's go ahead and do one last example, and then we'll actually just graph these together in class. That way this video isn't an eternity long. It's already kind of long, I apologize, but I don't want it to make it any longer. So for now, let's just go ahead, find the asymptotes, intercepts, domain, and range. Okay, intercepts is a new thing. Not a new concept to you, but it's a new thing that we haven't found for these guys yet. But let's find them. Okay, so let's start with the asymptotes. So for the vertical asymptote, okay, we can take our denominator and set it equal to 0. X plus 3 equals 0. Well, what makes that 0? It's -3, because we can just subtract the 3 over. So x is equal to -3 is our vertical asymptote. All right, let's go ahead and find the horizontal asymptote. Okay, so for this, we're going to divide the leading coefficients because they're the same degree. This is degree 1 and degree 1. So let's take the leading coefficients. This is 1 and this is 1. Well, 1 divided by 1 is 1. So we get a horizontal asymptote of y equals 1. All right, let's go ahead and find some intercepts. Let's start with the x-intercepts. How are we going to find the x-intercepts? We haven't talked about that quite yet here. Well, here is the rule. For x-intercepts, set, okay, there we go. Set numerator, there we go, numerator equal to 0. So let's do that. X minus 1 equals 0. Oh, that's not bad. X is equal to 1. So our x-intercept is 1, 0. Y-intercept, you know how to find this, right? F of 0. Let's plug in 0. 0 minus 1 over 0 plus 3. That's going to be -1 over 3, which is -1/3. So 0, -1/3. All right. And then just so we're kind of consistent with what we've been doing so far. In the previous examples, we've found some function values, some y values for numbers on each side of the vertical asymptotes. Let's do that again. Okay. Numbers on each side of the vertical asymptote, we have -4 and -2. So let's do -4 and -2. Okay, so f of -4, what do we get? -4 minus 1 over -4 plus 3. -4 minus 1, that's -5. -4 plus 3, that's -1. We get 5. So another point on the graph is -4, 5. And then f of -2, we're going to go ahead and get -2 minus 1 over -2 plus 3. -2 minus 1, that's -3. -2 plus 3, that's 1. So we get -3. So then another point on the graph is -2, -3. Okay, so we went ahead and we did a little bit of extra just to be safe. We found our asymptotes. We found the x-intercept, the y-intercept, some extra points on the graph. Let's go ahead and finish up with our domain and range. Okay, it's always just based on the asymptotes. Our domain, it's everything except -3, so x cannot be -3. Our range, it's everything except y, or sorry, 1. So y cannot be 1. Cool. So then you can go ahead if you're curious, and I encourage you to do this actually. So this will be kind of your one last thing to do to finish your math homework for the day. Go ahead and just graph this in Desmos and just see if you can confirm all these pieces. See if you see all of this stuff on the graph. Okay, And if you're looking at the graph, you're like, I don't know what this is, Mr. G. We're going to talk about it in class, okay? Thanks for sticking around for this whole video. I apologize for the length, but it's just stuff we got to get through, okay? Have a great rest of your night, Algebra 2. I will see you tomorrow. Bye-bye.